The new chapter for the session is surface areas and volumes. What is the surface area and what is the volume? Now that we have discussed about area and perimeter in a solid closed figure, similarly we have the concept of surface area and volume, which mainly comes in the three-dimensional zone. So let's see in brief about surface areas and volumes of different solid figures. For example, if I have a different sheet of papers, say for example I have this paper which is rectangular, we know that this sheet of paper, when just understood, is understood as a rectangle with length and breadth. But what if I start adding another papers, like I had the set of papers joined together? So when the set of papers are joined together, then it seems to form a solid figure. So this kind of a solid figure, which is formed by each sheet of paper combined together to form a bundle of papers, is what makes us enter into the concept of surface areas and volumes. Similarly, if I take the example of this is a rectangular plank. This is length and this is breadth, but this is the length and this is the width, and also we see that it has slight thickness on the rim. So if we take into consideration even the three-dimensional thickness along with the length and width, such a concept makes us introduce or enter into the zone of surface area and volume. For a solid object, we also take into account the thickness, and this makes us understand why surface area and volume come into existence. So let's recap with area. As we have seen that area is this total region occupied by the closed figure. So this is the area of this face, but this being a solid object has areas in all the different directions. It has area here and here and here and here and here and here. So totally there are 6 different faces for this shape, which is called a cuboid in mathematics. So when it comes to a cuboid, let's draw a cuboid and just understand the concept. Here is the cuboid, assumed to be seen from this angle. Now there are totally 6 faces: face 1, face 2, face 3, 4, 5 and 6 down. So each of the faces have their own area, assumed to be a rectangle. So surface area is the area of each face of the solid figure. So we understand the surface area is defined as the area occupied by each face of the solid figure. So the surface area is defined as the area occupied by each face of the solid figure. So in this case, there are 6 faces which occupy 6 different areas. So when you add up all the 6 different areas together, then the total area is called the surface area of that object. In this case, it's a cuboid. What is the volume? So in general sense, as I see this object to occupy some space, like for example, this object occupies some space. So any object in universe which occupies space is called the volume. It is the capacity, and hence let's define volume in terms of the capacity of this box is to occupy this much of space, and hence its volume is what it occupies in the space. So, in general terms, the volume is defined as the space occupied by the solid figure, or sometimes we also call the volume as capacity. So the volume is also called the capacity in some other means of understanding the volume. So here the volume is defined as the space occupied by the solid figure, and the surface area is defined as the area occupied by each face of the solid figure. So each face area when added up gives me surface area, and the space which the object occupies is defined to be the volume of the solid figure. Is how we understand the surface area and volumes of a three-dimensional object. Now that we have discussed about surface area and volume of a solid figure is understood through the different faces as taken into consideration. Now let's see how we can find the surface area of a cuboid. This session is about surface area of a cuboid. Cuboid surface area. So how do we find the surface area of the cuboid? Let's see in brief. Imagine I take a cuboid which is in the shape of a box. Here is the cuboid, and here I have said the length of the cuboid is this, and the width of the cuboid is this, and the height of the cuboid is this. If the length, width and the height are given to be L, B and H respectively, then the surface area of the cuboid is nothing but the area of each of the 6 faces 1, 2, 3, 4, 5 and 6. So top, bottom and all the round faces make the surface area. So for such cuboid which has all the faces covered, we have surface area of the cuboid is 2 times of LB plus BH plus LH unit square. That's how we define the surface area of the cuboid. So the surface area of the cuboid, which covers all the 6 faces with length, width and height, is given by 2 times LB plus BH plus LH, where L is length, B is width and H is height. Surface area of a cuboid given by the formula. Now that we have discussed about surface area of a cuboid, let's see how we can apply to a real life problem. How to find the surface area of a cuboid whose dimensions are given using the formula. So this session is about applications of surface area of a cuboid. Applications of a cuboid. Say for example, the question says, find the surface area of the following cuboid. Then we have a cuboid which is like this, and here I have to find the complete surface area of this cuboid. So let's see how we can find the surface area. The dimensions out here are given to be 14 centimeter, 10 centimeter, and 4 centimeter. So let's see how we can use the surface area formula to find this. Clearly, the dimensions 14, 10, and 4 are nothing but the length, width, and height which we identify in the diagram. So for this cuboid, I identify that my length is 14 centimeter, my width B is 10 centimeter, and my height H is 4 centimeters. So LBH, length, width, and height are given out here. So using LBH, we have surface area of cuboid, which is given by the formula 2 times LB plus BH plus LH. So LB is 14 times 10, LB plus BH plus LH is what we get when we substitute L equals 14, B equals 10, and H equals 4, which on simplification gives 140 56. And this comes out to be 180 and 236. 472 is what we get. Therefore, area of the given cuboid is nothing but 472 centimeters square. centimeters square is the area of the given box or the given cuboid with length 14 centimeters, width 10 centimeter, and height 4 centimeter. Its area would be 472 centimeters square. Is how we apply the formula into the application based problem. Now that we have discussed about surface area of a cuboid, let's see how we can understand the lateral surface area of a cuboid with its real life model. Today's session is about lateral surface area of a cuboid. lateral surface area of a cuboid. So here is a cuboid with length, width and height. Now as we have seen that there are 6 faces, 1, 2, 3, 4, 5 and 6, the top and bottom. So if you add each of the 6 faces, we get the total surface area or the surface area of this entire cuboid. But if we just exempt the top and the bottom faces and we go laterally along the side, straight line along the side, then such an area is called lateral surface area. So the laterally surface area does not include the areas on the top and the bottom. It includes only the surface area on the sides. So face 1 plus face 2 plus face 3 plus face 4 make the lateral surface area. This and this does not come into account. So we understand that lateral surface area is the surface area of the cuboid which does not include the top and bottom. It includes laterally the side faces. So let's see in this session how to find the lateral surface area of a cuboid. Imagine I take a cuboid . Now here, this is the length, this is the width and this is the height. Now as I include only the 4 faces but not the top and bottom, this is not included and the bottom part is also not included. Only the face 1, face 2, face 3 and face 4 are included. Let's see how we can find lateral surface area of the cuboid. So here the definition says lateral surface area denoted by LSA is the area, is the surface area of the cuboid which does not, which includes all the faces which includes surface area of all the faces except the top and bottom faces is how I understand the lateral surface area. The area of the cuboid which includes all the faces except the top and bottom. Therefore, using that definition of the lateral surface area, therefore lateral surface area of a cuboid is given by LH and LH there and BH plus BH. Therefore, I have only 2 times of LH plus BH. I do not include the top and bottom which is LB, so it has only LH plus BH. That's how we understand the lateral surface area of a cuboid. 2 times LH plus BH. The top and the bottom faces are exempted in lateral surface area. Now that we have discussed about lateral surface area of a cuboid, let's apply in a problem. So let's see the applications of lateral surface area, how to find the lateral surface area of a given cuboid. Applications of lateral surface area. This is for a cuboid. So let's see how we can find the lateral surface area of a cuboid as the applications. Here is a rectangular cuboidal box. And this is 10 meters, and this is 8 meters, and this is 5 meters. So let's see how the lateral surface area, that is, which covers only this region and this region, but not the top and bottom, the other two sides. So the question here is, find the lateral surface area for the given cuboid. So let's see how we can do it. As clearly we have the dimensions, my L is 10 meters, my B is 8 meters, and my height is 5 meters. So I have my L, B and H, which I'm going to use in finding the lateral surface area. So in this case, lateral surface area of the given cuboid is given by the formula 2 times LH plus BH is what we have seen. So let's use this formula to find the lateral surface area. LH plus BH. So this comes out to be LH plus BH, and then 2 times 90, which is 180. Therefore, the area of the lateral surface area of the given cuboid is 180. Therefore, lateral surface area of the given cuboid is 180 meters squared. Is how we understand the lateral surface area, which can be found using the dimensions of the cuboid. In this case, the answer is 180 meters square. Applications of lateral surface area into the real life models. Now let's discuss about a cube. What is a cube and how do we derive from a cuboid? We have discussed the various properties in a cuboid, the total surface area and the lateral surface area. Now comes how we can take a cube as a special case of a cuboid. Today's session is about cube as this 3-dimensional solid figure. We all have come across the Rubik's Cube, the one through which we solve the game. A Rubik's Cube is a perfect cube because it has all its sides equal. So what is the special case? So we say that a cuboid whose all its sides are equal, such a cuboid is called a special name called a cube. So if I have all the sides being equal, then this is a cube because it has all its sides equal. This is an example of a cube because, say, this side is A, this side is A, and this side is A. Its length, its width, and its height are all equal in length. So we can define a cube as seen here with the dotted region . A cube is a special cuboid in which all its sides are equal in length. If you take the example of this, the length of this is not equal to length of this, or the length of this is not equal to length of this, or the length of this is not equal to length of this. So this cannot be a cube because a cube has a special case, is a special cuboid in which all its sides are equal in length. This length must be equal to this length, must be equal to this length. All its lengths must be equal. Only then we call the given cuboid to be a cube. A Rubik's cube is one of the example. We all know what a Rubik's cube is. So such a solid figure is given by the name cube. Cube is a special cuboid in which all its sides are equal in length. Now let's see what is the surface area of this cube to be followed with. Let's see now the surface area of the cube. So let's take a cube, as we have defined a cube to be a cuboid in which all its faces are equal. So here is the cube. And for this cube, each face are equal. So this are equal. Now for this cube of side A, we can find this total surface area or the surface area using the formula. Total surface area, or simply the surface area of a cube of side A is given by surface area of cube equals 6a square unit square. That's how we understand surface area of a cube as 6a square unit square. If I have a cube of side A, I can find the surface area by using the formula 6 times a square. Now that we have discussed about a cube and also about finding the surface area of a cube using the formula 6a square, let's see one of an example problem as the applications of surface area of a cube. This is about surface area. Now here I have a question which says, find the surface area of the following cube. So here I have a cube. And I need to find the surface area of this cube in which the side is given to be 5 centimeters. So surface area of the cube. So how do we find surface area of this cube? We have the formula directly, where first I identify that my A is 5 centimeters. So using A equals 5 centimeters, surface area of the given cube is 6a square, formula 6 times a square, which is 5 square, and 5 5 is 25, 25 6, which is 150. Therefore, surface area of a cube of side 5 centimeters is given to be 150 centimeters square. Is how we understand the surface area of a cube of side 5 centimeters is 150 centimeter square. Applications of surface area of a cube to an example problem. Now that we have discussed about total surface area of a cube, now comes the question on lateral surface area of a cube. As we have seen the definition of lateral surface to be the area of each of the faces which are on the side, excluding the top and bottom faces. Let's apply the same concept of the cuboid into the cube. Lateral surface area. So what is a lateral surface area of a cube? So let's take the diagram. Here is the cube. So let's see the area of this cube with side A, the lateral surface area of this cube with side A. Clearly we see that there are 4 faces excluding the top and bottom face, which makes the lateral surface area. So each of the faces is a square, therefore as we take the dotted region, there are 4 squares of side A which make the lateral surface area. So totally there are 4 squares which make the lateral surface area, and each of the square has the area A square. So 4 times of A square would be the lateral surface area. That's how we understand the lateral surface area of a cube. Therefore, lateral surface area of a cube of side A units is 4 times of area of each square, which is 4a square. Is how we get, because area of square is a square. Therefore, LSA of a cube is 4a square (4a square unit square), lateral surface area of a cube. Now that we have discussed about lateral surface area of a cube, let's try to apply in a problem. So, applications of lateral surface area of a cube. So, if I have a cube So here is a cube of side 7 meters, and my question is, find the lateral surface area of a cube of side 7 meters. So here is a cube of side 7 meters with all sides being equal. Now we need to find the lateral surface area. Now 7 meters is the A which I identified. So my side A is 7 meters and lateral surface area of a cube is given by lateral surface area of a cube is 4 times of A square, is what we have seen as the formula. 1, 2, 3, 4. 4 faces or the 4 squares which are taken into consideration. So let's see how we can add up. Now that we know the value of A is 7, I just substitute the value of A, which is this 7 sevens 49 meter square is what we get. So here the lateral surface area of this cube is 196 meter square. Therefore, LSA of a given cube of side 7 meters is 196 meter square. This is what we get. The lateral surface area of this cube of side 7 meters is 196 meter square. Is how we conclude the applications of lateral surface area for solving the problems.